Hello, good afternoon, everyone. Can you all hear me? Are you all okay after the lab that day? Anyone not feeling well? Headache, headache because of the lab. I hope it's not one of the symptoms in COVID. Okay, okay, right. So, yeah, I think most of you already submitted your case study assignment, but then, um, yeah, but then I think some of you forgot to submit the Turnitin. Suppose I need to have two files in your submission. Yeah, one will be the Turnitin report with how many percent. Another one will be your full report, full final report. Can you get it? So for those who haven't, submit the Turnitin or or yeah, if you only submit the Turnitin, then you please submit your final report. Okay, so you still can submit, right? I think you can submit more than one time, right? Yeah, I can. Can. Thanks. So you submit one report, one final report, and another one will be the turn-in report. Okay. Thank you. And if can, then you please rename your file to your name. Okay, because that is easier for me lah. Else I will help you to rename all the file. Okay. So for the lab report, please when you do the submission, lab report no need turn in. You just need to submit your final lab report. But then please rename your the file name to your name. Easier for me to know which one. Okay. Mm, okay, then continue with our lecture notes. Today suppose today we already go through result theory. Tutorial is it? We stop until I think tutorial 2 I think all done right. Tutorial 3 most of the question done I think except which one is it? No story one is it? I think question 3 not sure is it? Is it tutorial 3? Have we settled all? Question 3 and 5 I think not yet. Then we should go to symmetrical components. Tutorial 4. Hello. Is it? Any one of you let me know? Is it question 3 not yet? Tutorial 3, question 3. Yeah. Okay, then we discuss tutorial 3, question 3 now. So means all of you are okay, right, with the arrangement into the recording. Any problem so far? Uh, this week all classes will be online, including the tutorial. Okay, because supposedly I need to self quarantine until I don't know 5 days. Suppose it's until today, but then AD told me to to have classes online for a week for this week. Okay, so no physical class. Are you okay? And actually, I don't know why. Yeah, it's very scary. I don't know why. You know, last week actually I only have two classes. One with you, right? Another one is with the RE student lab, circuit analysis lab. Then your class have one student said positive. Another class is, I think she is recovering. Another class, circuit analysis class, also have one student positive. Oh my god! Then I say like I nearly like 100% kena already. I mean not kena lah, I mean the chances of it, others conduct my other colleagues conducted the physical class for so many times also not really have any students positive. But then last week I only conducted two classes and that's my first and second classes, and then every class have one student positive. But then the other class still okay because he actually get positive. I mean, get to know his family positive before the class. And then I asked him, you better don't come. then oh okay, after that he's positive. So but then he's actually not attending the class, so it's still okay. But then I don't know why. I don't know why that like I'm like my classes are very high chances. Okay. And nobody reported before, about the students positive. And I straight away report two cases. So funny. Um I think maybe you are too um yeah too happy, right? Always go out and have fun. Okay. Mm. Then so that's why in February I will make it to online classes. So my planning will be maybe the tutorial classes make it physical. So for anyone who like to meet me and then for discussion. But not this week, not this week because Eddie said asked me to have online class this week. Okay. So it means this week online. So never mind, I will always make weekly announcement in the Google Classroom. So that's why you are here now, right? So because you actually get to know today class from Google Classroom. So you just follow up the weekly update from Google Classroom. Okay, thank you. So let's look at tutorial 3, question 3. So a single phase 50 kV 2004 240 watt 60 Hz distribution transformer is used as a step down transformer. Normally distribution transformer will step down because they want to distribute the voltage to the power electricity to the load. Okay, so the load end will be 2004 watt feeder whose series impedance is 1 plus 2 j ohm, and then series impedance of the transformer refer to the high voltage side. The transformer is delivering rated load. Okay. Then they want you to find the voltage at the transformer primary voltage. Can you understand what they actually want you to do? It is basically this will be the transformer. Yeah. Series impedance. It means the so-called the cable, the feeders impedance, the line impedance, and then this will be the impedance of the transformer. So it's basically if you draw the circuit out, it is basically something like this. Like maybe I just make a box. 1 plus 2j, and then another one 1 plus 2.5j, and then it will be your transformer, and then there will be a V2 equal to 2400. 2400. So V2 will be 240. Okay. So your V1 is actually here. Your V1 is actually here. Yeah. Can you? So your V1 is actually what? 2400 angle 0 degrees. So the diagram is something like this. Then what they actually want is the voltage at the transformer primary terminal, the voltage at the sending end of the feeder. So sending end of the feeder will be here. So this is Vs. So here you can put in plus minus V1. So basically what they want is here. For part A is here. Okay. Why they say transformer primary terminal? So because this 1 plus 2.5j is basically the series impedance of transformer. So means your transformer start here. Okay. So this is actually something like the cable. Okay, from the feeder. Feeder means like cable. So you come here, then you stop here, then it connected to the transformer impedance and transformer. Okay. So part A will be you need to find V1. So what is your V1? So in order to know V1, sorry, this one you don't call V1, this one you call E1. E1 is the transformer set up down. So this one 240, then here will be 2004. So if you want to find V1, it's basically voltage here plus V1. So if you want to find the voltage here, then you need to know, maybe you got I1 current I1. So how are you going to find current I1? If you want to find current I1, then you can find I2 first. I2. Okay, once you get I2, then you can use the transformer ratio to find I1. Are you okay? So how to find I2? So basically I2 will be equals to S2 over V2 conjugate. Okay, means S equals to VI conjugate. So are you okay? Then S2 they actually give you already, right? Just now they say the load something here. Transformer is in the rated of 0.8 power factor lagging at rated secondary voltage. So at rated means it is actually 50 kVA. 50 kVA with 0.8 power factor lagging. So from here, you can actually write down, right? 50k, and then shift cost 0.8. So suppose it should be positive, but then because of the conjugate, then because of the conjugate, then we make it negative here. Can you see the negative? So we make it negative here for the angle. Then we remove the conjugate. Then V2 will be 240. Is V2 at the 4. So I2 is basically equals to 208.3 angle negative 36.87 degree M. Are you okay? So once you get I2, can you get I1? I1 will be equals to N2 over N1 I2. Then you get 20.83 angle negative 36.87 degree. So once you get I1, then can you get your V1? So V1 will be equals to E1 plus 1 plus 2.5J times with I1. So E1 will be 2004. I1 you have the value already. V1 is the thing that you want to find. So suppose you can get the value. Suppose you can get the answer 2448 angle 0.683 degree, right? Oh. Any question? This is answer for part A. No, not about equivalent circuit. It is not about equivalent circuit. Yeah, they ask you to, the so-called equivalent circuit here is actually the, I'm thinking about the practical transformer. No. The equivalent circuit here, it means this circuit lah. It's not about the practical transformer circuit lah. Yeah, it's the equivalent circuit. It means it's actually this circuit. Means the circuits to represent those sentences. Okay. Are you okay? Then part B, they say they want to have this VS, the feeder side, sending end of the feeder side voltage. Then again, you can still use which one? The practical transformer. Don't use a practical transformer, because actually there's already sent neglecting the transformer exciting currents. So supposedly it should be under ideal transformer. By the way, normally will be ideal transformer. Yeah. Your questions normally will be ideal transformer, unless this kind of questions. Okay. So this equivalent circuit is not about the practical transformer circuits. It's actually just a circuit to represent these sentences. Ascending end of the feeder, it means here. So why they ask you to draw out these circuits? Because if you have these circuits, then it's easier for you to imagine. Supposedly it should not be series impedance is actually okay one, because this series impedance is just the impedance of the transformer. Is quite normal. Then another one is actually the impedance of feeder is a cable, the transmission line impedance value. And this one, if you still remember when you do the per unit, right, you also find the impedance value for the transformer, right? Do you get what I mean? So I think it's still okay. It's not really about the idea or practical. I think still okay. Okay. Then part B. Vs will be equal to, so if you want to find Vs here, so it will be voltage here plus V voltage here. So if very current I1, then basically you can use I1 multiply with this impedance plus this impedance, right? So I1 1 plus 2J plus 1 plus 2.5J, then plus with E1, okay? Plus with this E1 value. So voltage here plus voltage here. So you got it. I think I don't want to substitute the values. You should be able to substitute and then get the answer. 2490 angle 1.1505 degree. Okay, Nicholas. Yeah, because it's just a impedance of the transformer. Everything you need to have something to represent the transformer, right? So like what we did that day, we also have XT transformer, right? Impedance of the transformer that we, you get what I mean? That we do this kind of questions, right? So we also have the impedance transformer. So I think it's impedance transformer is not a problem. But then leakage reactance, these are exciting current, then of course it won't be what you call ideal transformer. But no worry, your level, your standards, in the exam normally will be ideal transformer. Okay, then the real and reactive power delivered to the ascending end of the feeder. And this is just a very fundamental paper of power system. Electrical stream, the most fundamental paper, so it's not that tough at all. Okay, the real and reactive power delivered to the sending end of the feeder. So once you get the voltage and current, want to find power is not a problem, right? But C, sending end power will be V voltage sending end Vs current sending end, then conjugate Vi conjugate. So will be equals to 40 point. Okay, you can multiply Vs here, multiply by Is. Is is actually I1. Is and I1 is the same. Here Is. Is and I1 is the same. Is equals to I1, substitute this value, multiply with this Vs value, and conjugate it, then you should get 40.87 kilowatt plus J 31.95 kVAR. So they said they want real and reactive power, right? So this kilowatt will be real, this one will be reactive. Real and reactive power, right? Yeah. So this one will be your P, will be your Q. Are you okay? Any questions? Are you okay? Renjian? Minghan? Yingxue, are you okay? Okay, great. Then the next questions will be, I think it's the last questions, right? Use a transformer rating as a base quantity. Revert question 3 in per unit. So it's the same question, but then now instead of now you are using M and voltage, right? But then now they want everything in per unit. So how are you going to do it? So let me use the other color. Let me use blue color. So they say that you need to use the base is actually transformer rating. So it means transformer rating here 2004 and 240. So what does it mean? So here will be 1 pu. Yeah. Okay. So here you cannot use 1 plus 2J and 1 plus 2.5J anymore. Yeah, so you need to find out what is your Z base. So your Z base equals to V squared over S. V will be this side will be 2004. Okay, 2004 squared divided by S will be 50K. Yeah, 50K. Then you get 115.2. So this one you need to divide 115.2. So you need to divide 115.2 in order to get the PU value. Actual divided by the base. So you get the PU value. Then here I2 here. I2 is basically, yeah, it's basically divide, now is equal to 1 pu. 1 angle negative 36.87 degree pu. Okay, so this one will be equals to 1 pu again. Is here also 1 angle negative 36.87 degree, 1 pu. Then here, yeah, you substitute. So you need to divide it by 115.2, right? Yeah, 115.2. This one you need to divide it by 115.2. Then E1 value will be 1 pu. So will be 1 pu. So 1 pu plus with this one, 1 plus 2.5J over 115.2. Then times with I1, this one 1 angle negative 36.87 degree. So basically you get 1.02 angle 0.683 degree pu. Okay. And same thing. But then here you need everything you need divided by 115.2. 115.2. 115.2. Okay? You okay? Then I1, you need to multiply with 1 angle negative 36.87. E1 will be 1 angle, 1 pu, yeah, 1. Then you should get the answer here should be, part B should be 1.0375 angle 1.1505 degree pu. Yep. Then SS in pu, again the same thing. So you use VS in pu, multiply by IS in pu, what you get. So you should get 0.8173 plus J 0.639 pu. Are you okay? Oh, why I1 equals to 1 pu? This is a very good question. Because basically your I2 is actually S2 over V2, right? V2 is 1 pu already. S2 also 1 pu because you are using the same. You are using back. Okay, this is actual, right? Actual S, right? Then you are using the same 50 kV as your base. You got what I mean, Nicholas? Then same as your voltage. Voltage is using back the same reference as the base. So definitely your voltage will get 1 pu, right? Your voltage will get 1 pu. Your power S here, complex power will get 1 pu. Then definitely your I2, your current will be 1 pu as well. You got what I mean? Actually, I already shortcut a bit. So if you want to do it exactly, that means this one not S2 also you can find out 1 pu. 1 angle negative shift cos 0.8. Why 1 pu? Because the actual 50k, okay, you divided by the reference also 50k. Can you all understand? It's the same way of doing, just that the main thing will be here lah. V square over S to get the impedance space value 115.2. So you divided by 115.2, and yeah, so means that all the impedance you need to divide by 115.2, and then others would be 1 pu. Are you okay? Are you okay? Are you okay? Oh, it seems like a bit lacking. I need to ask 3 times and only you all can reply. Yeah, this okay, this chapter, okay, I mean supposedly we done the discussion for this chapter. Okay, this chapter power transformer, I can tell you the main thing will be this kind of very simple impedance. I mean refer the impedance mapping. Refer to the primary, refer to the secondary side, and then and then will be this one. This kind of thing is more important. Okay, this kind of question is more important. So this question 3 and 5 is still okay lah, not that important. Okay, but then it won't be very tough also. If I ask, then roughly will be like this also. Okay, I mean actually because the question not really have a lot of pattern to change. Okay, and if you okay, then tutorial 3 we officially end. The main thing will be the per unit concept in this chapter. I will tell you. Okay, then how to draw the impedance. So you need to definitely you need to make sure you know how to draw out the impedance diagram. The new new power 2, that one. Okay. Then, but don't worry, I will still give you all some. I mean during the revision past year questions, there are a lot of questions about this kind of diagram. So we are going to to do more on it. Okay. Then tutorial 4. Tutorial 4. Still, can you all go through the recorded video in tutorial 4? I go through with you already, right? The lecture 4. I still remember I tell you. Still remember what I tell you? The main thing will be the two formula, one formula to convert the phase sequence. Phase here, ABC is phase, 0, 1, 2 will be sequence to phase, and yeah, sequence to phase or phase to sequence. These two formulas only. Okay, and I told you the good news and the bad news, right? Yeah. I can't open it. Yeah, don't remember. Yeah, like Edin can remember, right? John can remember. The good news is, why I cannot open it? Why it open in my okay, never mind, I use what is the good news? Anyone can remember what's the good news? No formula, got formula. Yeah, John is very focused in the class. Very good. Current is having the same formula as the voltage. Yeah, you still have the voltage, and then you have current, right? So current and voltage is the same formula, just that I change to V change to I only. Then the bad news is, yeah, no formula list is given in the exam. Okay, so you need to memorize it. Good news, online final exam. Actually, I think most probably will have online exam because, right, looking at the very high COVID cases like this, and then you see suddenly one of the, don't say you are one of anyone in the same COVID positive, then somebody become close contact, then you cannot attend the other paper. Then also very suicide. I feel so lah, but then we need to. I mean, I feel so only. Okay, but then secret department already asked us to prepare another set of questions ready for online. This is what I can tell you, but then not yet confirmed. Not yet confirmed. So not yet confirmed. Yeah, that's a sorry. Okay, so they say if online, then the question should be harder. Okay, harder. So it means no law. No, last time online also people cannot pass EMF. It doesn't make any difference. So don't be so happy first. Okay. But then for my paper, don't worry, online or physical, you sure can pass one if you effort. Okay. I mean, if you know all the basic things, I mean the tutorial, okay, everything that I tell you that is important, you can do it, then supposing you can pass. Yes, EMF is still hard regardless of online or physical. So don't be that happy first. And they have to wait for UC final announcement. This is just my opinion only. Okay. So we need to wait and see if any announcement about whether online or physical final exam. But then seriously, if doing physical is very tough. So not to say the students if the lecturers same venue then attend and be the invigilators because of becoming the close contact, then siapa jaga. So it's also a problem. Okay, this one I think I want to show you the answer. Okay, because actually nothing. So determine the symmetrical component of line current. So IA, IB, and IC they give you already. Now they want to find I1, I2, and I3. So basically, where's my PDF? I close it already. So basically, what is the formula that you need to use? Chapter 4. You want to find I1, I2, I3, right? Okay, you want to find this one. You want to find I0, sorry, not I1, I2, I3. I0, I1, and I2. Zero sequence, positive sequence, and negative sequence. So can you simply change the name? Cannot, One definitely stands for positive sequence. Two definitely stands for negative sequence. So you have to use this formula. Okay. Then what is A? A is 1 angle 120. So basically it's just formula Let me off this one first. Okay. Yeah, this one. So you just need to use the formula, put it in, and then you get the answer. Are you okay? No, it's not better of die or not. So it's because you're okay lah. But then our side, lecturer side, we have small kid at home, so that's why we worry if because they haven't get the injection. Okay, and also worry about the side effect of COVID on the kids. Are you okay? This okay? So basically, this formula you substitute in this one is IA, IB, and IC value that is given in the given in the question. So IA, IB, and IC. Then put in the formula. So what is A? So A is basically one angle 120 degree. So this is not really that good. Suppose you need to write down a more detailed 5/3. I didn't 5/3 actually no need okay. But I mean they factorize out the 5 actually no need. Straight away use calculator. But then I need you to show me here. This is 1 times 5 angle 90, right? This one is A times this one, right? So I want you to actually I prefer you to show like this. Here actually you should show A 1 angle 120 degree multiply with what 5 angle 320 degree then plus A squared. That square will be what 1 angle 240 degree multiply with the 220 degree. Can you get what I mean? It's a very easy thing, but then I want to see your steps. Okay. Some more if online exam, how I know that you are not copying your answer from your friend there. So you need to show me the steps. If you show me only the final answer, I will deduct a little bit of marks. Okay. Then this will be the answer. Okay, I prefer the answer in this format. Polar format. Okay. This is rectangular format. Of course, if you give me in rectangular format, I won't give you wrong. But prefer in polar format so that I can mark faster. Okay. Any question? Then part 2, question 2. Are you okay? Just a formula only. Too easy, right? No challenge at all. Okay. Given that the symmetrical component V0, V1 to this, determine the phase. So this one will be from sequence to phase or sequence to phase. Where is it? Sequence to phase. A sequence to phase. Sequence to phase. This one, sequence to phase. So it's basically 2 types of formula only. So sequence to phase. So V0, V1 plus V2, then it's settle, we get VA. So VP, then VC. This way of writing the steps is good. This is good. Okay, then this one, fine answer. Okay, any question? Calculator, you know how to use, right? Change it to complex number, then just follow whatever that 10 angle 0 degree. Plus 120. Don't simply plus because why plus 120? Why plus 120? You want to say that angle under angle multiply is actually angle multiply is angle plus. I a little bit worried lah. So normally I will ask the student to multiply lah. So you use calculator to type to press like this 1 angle 120 degree multiply with 4 angle negative 30 degree. But steps you need to show lah. But definitely if you are very good in mathematics, you think you very confirm that it's actually plus, then okay lor. I actually didn't check so then you can give me final answer. Okay. You double check. I think what I remember in maths is actually angle multiply is angle plus but then I don't know, I rely on calculator a lot. So normally I will ask students to press straight away lah. Then you don't, maybe later may have careless mistake. Okay. So it's very easy questions. Very easy that actually I don't want to spend more time here. Okay, use the result in part A. Then in part A, now they want to calculate the line-to-line voltages VAB, BC, and CA. If you already have VA, VB, and BC, can you find VAB? So VAB will be equal to VA minus VB, VBC, VB minus VC, VCA, VC minus VA. So once you get VAB, VBC, and VCA, then determine the symmetrical component of this line-to-line voltage. So nothing. You find out AB, BC, and CA, then use the formula again, convert to 0, 1, 2. Understand? This VAB, VBC, VCA. Then find out 0, 1, 2 sequence by using formula. Are you okay? My answer here actually a bit maybe a bit different from yours because it actually round off quite early. Like this 0, right? Supposing maybe not sure. Maybe you get 0. Maybe 0.5 or 0.6 or 0.0 something lah. Then it actually round off to 0 already. Okay, so if you have slightly different from my answer, actually it's okay. The step, as long as the method and the steps are correct, then okay. You follow whatever that is shown in your calculator. Okay, this one they actually, my answer here actually they round off a bit early. Any question? If you think this is very easy, then please type 1. If you think you totally can't understand, type 2. Just do a quick survey. How many of you actually understand what is happening? Understand, right? What's the point of finding VAB 0, 1, 2 again? Not the point, it's actually the question. The question says so much. Then determine the symmetrical component of this line-to-line voltages. So means after the AB, BC, and CA, then they want to find out the symmetrical component only. Understand, Nicholas? Actually, but like what you say, I also feel no point. So it's just a question asked to do so. Matrix or not doesn't matter. Matrix or not is just a way of writing only. You want to write equation like this also can. You want to write in matrix format like this also can. Understand? It's actually just a way of representing the formula only. They are actually the same thing. Nicholas, do you get what I mean? You don't want that. This is equations, right? Then in 9, then this one is a matrix format, right? You don't need to write in matrix format. It's okay. So it's up to you. Some prefer matrix format like this because it looks neater, a bit neater. Then actually up to you. You write like this also can. You want to write equation like this also can. Okay. Then now actually still formula change here and then only. Question 3 also formula change here and there. I think question 4 onwards a bit about the unsymmetrical. This one kind of questions is more about the unsymmetrical unbalanced load. Unbalanced load. Then you have load here, but then you don't have load here. So it's unbalanced load. Then how they apply this kind of symmetrical sequence formula to solve this kind of problem. We only have 7 questions. Okay. Then question 1, 2, 3 done. 3 also same thing, just a very intro question only. Line to ground, VAG, VBG, VCG, the values given, then sequence component. So from here, you need to find what? 0, 1, 2. Okay, so use a formula. Yeah, use a formula to find 0, 1, 2. So actually, normally I won't write LG or like this one AP, I won't write. I will straight away V0, V1, V2 only. Okay, so formula only, I think okay, right? Am I too fast? You need time to copy or not? Or you can just print screen, right? Do you want me to post for you to copy the answer? Okay, I just go out. Then if you, I just carry on. Yeah, yeah. If you need me to let you copy or what, then you ask me to stop. Okay. Then part B and C is the same, right? I think part B and C. Then after you get the sequence component, then they ask you to find the line to line voltages BC, AB, BC, and CA. So basically, you already have AG means EA lah. So you have VA minus VB, you get AB. BC minus VBC means VB minus VB minus VC, VC minus VA for VCA. Okay. Then again, they ask you to find the sequence component 0, 1, 2 for this. Okay. So basically, VA minus VB, VB minus VC, VC minus VA, then you get the value for VA, VB, VC. Then convert again using the formula to find 0, 1, 2. Itu sahaja. This one no need lah. I don't know why. Yeah, give answer in polar form. Can okay? Are you okay? Then will be next question. The voltages arise in Q3 are applied to the balanced Y load. Okay, now they give you a balanced Y load. The load neutral is solidly grounded. Draw the sequence network and calculate I0, I1, I2. And then the sequence component of the line current, then calculate the line current IA, IP, and IC. Now it's just a voltage, right? So now they want the voltage applied to a Y load, and this Y load values is given. So you get what I mean? Where is it? I don't think it is. This one, yeah. This one actually got one small problem. There's a line here. Okay. So from the values, voltage values, I think it's given in B3 question 3. A, B, C, A, B, C. Okay, VA, VB, and VC. Then they want you to find I0, I1, and I2, right? Are you okay? So this one will be the question. So because it said it is Y load, yeah. Again, this one is some more small things that you need to take note. Balance Y load. If balance Y load, then and then load neutral is solid grounded. That means all of them is actually same circuit like this. Okay. So if it is a delta load, that means your zero sequence here, zero sequence. You need to load here, right? You need to have open circuits. Okay, only for zero sequence. That I think that day in the lecture notes. Never mind, I can show you again. I mentioned before, this another small theory parts that you need to know. And this one. If it is in delta load, then your zero sequence need to be open circuit, because delta load has no neutral connection. Okay, so the equivalent Y load has an open neutral. Okay, so only zero sequence you need to open. Itu saja. Okay, and then other things that you need to take note is you may feel very confused. Now have so many voltage, phase voltage, AP voltage, and then what voltage that you need to use, and sequence voltage. So you need to check question 3. They give you VA, VB, and VC. Then they find line to ground. Yeah, line to ground voltages. So you know that Y load Then Y load, of course, they will use AN, right? You know what I mean, right? Okay, Y load here. So of course you use VAN. Okay, VAN means AG lah. Are you okay? So here you are finding I0, right? You cannot use VA over Z0, understand? You know what I mean? All of it must be V0, V1, and V2. You want to find sequence, then you have to use sequence voltage. Do you know what I mean? Then I0, I1, I2, that's why you use V0, V1, and V2. That you get from just now. The answer from just now, V0, V1, and V2. Are you okay? Any question? And then after you find I0, I1, I2, you want to find IA, IB, IC. It's not a problem. Use the formula to convert only. Are you okay? And you only have current and voltage in sequence. You don't have this kind of impedance in sequence. So we still use 12 plus J16. Yeah, this one. It changed it to polar format already. This is actually 12 plus J16. Is it? This is actually this value. If you change it to polar format, okay, it will be 20 something angle 53.13. Are you okay? Okay, so one small problem might be here. So students may use VA, then divided by Z0, then in order to get I0 wrong, something like this. If you want to find IA, then IA, straight away IA, then you use VA, can you see? VA. Okay, so you don't use if you want to find I0, that means you use V0, V1, V2. This is a thing that you need to take note. Any question? Then formula to convert to IA, IB, IC. Any question? No questions, okay? Then repeat question 4 for the balance delta load. Okay, now they say that delta load. Okay, we can look at it. The answer. Can you see? It is an open circuit in zero sequence. Then delta load, right? Then they use ZY divided by 3. Okay, you can they change delta load to Y load, so you can divide it by 3. So basically I0 will be equal to 0 because open circuit already. Then I1 and I2. I think something wrong somewhere. I think there's a mistake here. 1 minute. Let me check on hard copy question answer. Mm, I think let me check. Why 272.4 there? Is it? Oh yeah. 272.4 is correct. 27.87. Okay. So so it take it from this value. Yeah, here. Yeah, this V1 value and this V2 value. Okay. So basically, correct. Okay. So you divide, then you use a load divided by 3, load divided by 3. So once you get your I0, I1, I2, then you can use formula to convert to IA, IB, and IC. Any question? Are you okay? This one. Then question 6, repeat question 4, but then there is a impedance line 3 plus 4J. So it's actually all of them same question. So no need. Yeah, here. Instead of only having the load, right? Now you add in a impedance, line impedance. Okay, so actually everything is the same thing. It's just that now you add in here only. Okay. Then you have V1, I1, I0, I1, I2. That also I equals to V over impedance. Okay. Then once you get I0, I1, I2, convert to IA, IB, IC. That's it. Are you okay? Are you okay? Am I too fast? Others? Are you okay? Ziyuan? Zhongjian? Brian? Okay. Then why okay? No, when I call your name, and at least I have a little bit of image how you look like. Last time I totally can't imagine how is your face. Uh, okay, then um okay, then we go to the next question. We only have 7 questions, right? We go to the last question, then we end tutorial 4. Yeah. Okay, this tutorial actually try fast is because it is actually not that important. The main important thing actually is just the formula only, convert sequence to phase, phase to sequence. Okay, then at the end, this chapter actually is linked with your unsymmetrical fourth chapter. So the unsymmetrical fourth chapter, you learn the concept there, then you need to apply this formula this formula to convert the sequence to phase, phase to sequence only. Okay. So that's why the tutorial here, I can say it's not really that important. Okay, as long as you know how to apply the formula. Okay. So as shown in figure Q7, a balanced three-phase positive sequence source with VAB. So VAB is here balanced. But then you apply to an unbalanced delta load. This is unbalanced. Suppose there is a line here, right? Line here, right? So you don't have, it's open already. Not that one leg of the delta is open. Determine the load current IAB and IBC. IAB and IBC. Okay, then you want to find the line currents IA, IB, and IC. Then the zero, positive, and negative sequence of the line current. How to do it? Yeah, this is answer. So IAB is basically VAB over the load. Then IBC will be BBC over the load. Okay. We want to find IAB, right? A point here, B point here. Then link with this A point here, and and B point here. IA. No, sorry. Normally we look at this point and this point. Okay. So what is the answer? VAB. So they use IAB. 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 IAB is here. IA actually is good. IAB. Okay, IAB. Oh yeah. Sorry. They give you VAB. Okay. I thought this VAB is here. No. VAB is plus minus here. Okay. Yeah, then right. So VAB is here. Then we give you us VAB. Okay. Then 480 divided by impedance, or then you get IAB. This is quite straightforward. Are you okay? So IAB equals to VAB over impedance. Then IBC will be VBC over impedance, because they say balance, so VBC will be 120 degree apart from each from IAB. Then you get this answer and this answer. Then they want to find IA, IB, and IC, right? So IA basically equals IAB from the diagram. IA kan equals to IAB. So IB equals to KCR. IB go in plus IAB go in equals to IBC. Okay. Then IC here going here equals to negative IBC. Understand? It's a current KCR and those current flow only. IB equals to IBC minus IAB, and IC equals to negative IBC. So then you get IA, IB, and IC. So once you get IA, IB, and IC, then they ask you to convert to I0, I1, and I2 use the formula. That's it. Any question? Line impedance is different from neutral impedance. Line impedance, you have the source, you have the load, right? Load here. This line, then we have the line impedance. And neutral impedance, different story. Neutral impedance is a neutral line, then they link to ground, then that impedance really. Nicholas, can you get what I mean? Okay. I feel good that I can answer your question. Any other question? Any question? Tutorial 4, okay? Today I'm going to discuss until tutorial 4 only. Means if you know question, then we can dismiss now. So if you have question, then we continue to discuss. So, do you have any question? See, I'm very excited that, so can't wait for you to say no question. No question, But no worry, seriously no worry, because this chapter is I know that it's a bit fast, but then it's actually just a formula only. Okay, the main thing is you need to know how to use this formula. Okay, and we will still use it again in revision again in unsymmetrical fourth chapter. So next chapter 5 will be I go through the lecture notes review, right? The transmission line. Then only have 3 tutorial questions. Only have 3 tutorial questions because 4 tutorial questions. Okay lah, this one from theory from the lecture notes already have. Okay, so only have 3 calculation questions. That is why so simple is because again it's not the main focus. This transmission line is covered in your lab assignment already, so it's not really I say, right? So then we go in symmetrical fault, and your test will be until symmetrical fault, midterm test. Then after that will be unsymmetrical fault. Then I say that you need to link back with the this kind of circuit and then draw the impedance diagram, and also use just now the symmetric the sequence formula. We have to convert sequence to phase to sequence. Then protection, power system protection, basically mostly theory. And also look at this graph, and then calculation for the economic dispatch. That's all for the whole syllabus. So means actually, no worry, we still have quite a lot of time. Okay, so if you don't have any questions, then we will end our class here. Bye. See you. Remember the case study assignment for those who haven't submit the turn-in report, the full report, please settle. Still processing. How come? Oh, you this is one problem in turning in because you think you can only try one time, is it, in the day? So don't over submit. 3 times in a day. Okay, Nicholas say 3 times in a day. So means that if you submit more than that in 3 resumption, so if you submit more than 3 times, I think you need to wait next day to get it. Yeah, but then actually I not did that because I think turning is until today only. So means after that you don't have turning in submission. That means you use the latest one that you have Okay. That one is just roughly to know whether you copy too much or not only. Okay, so Renjie Nicholas suggests you to refresh the page. Okay, that one I can't help. Maybe it's internet problem, or if not, then you can ask your friend to help you to submit to turn it in. Okay, now friends, help your friends. Okay, so that one I can't help much. If no questions, then we will dismiss here. See you. Take care. Bye.